This video is going to go over composite functions. Essentially what a composite function is it's one function inside of another function. I'll show you what I mean by that because I know that already sounds confusing, but first let's knock out these things right here. You can add, subtract, multiply, divide functions against other functions. So like what I mean by that is if I added f of x plus g of x, these equations, just combine like terms. So 4x and 2x makes 6x. Plus 3 minus 1 makes plus 2. Now, when you subtract them, you just got to be careful of you're subtracting the whole function. So you need to basically write it like this with the parentheses before your second function because it's going to be minusing the entire function. So you'll have to distribute that minus sign. So it would look like this, minus 4x plus 1. Now combine like terms. So 2x minus 4x is negative 2x. Plus 3 plus 1 is plus 4. So just pay attention that you actually distributed that minus sign to the second function. Multiplying them, you can just use FOIL or the box method. I use FOIL, so I shouldn't have to explain how to multiply a binomial times a binomial. If you don't know how I got this answer, please go watch a video on how to FOIL binomial times binomial. Dividing them, just put one over the other. So okay, now that we got that out of the way, we'll focus on substitution. Okay, now that we got that out of the way, we'll focus on substitution. Essentially what's going to happen here is whichever function is on the inside, so like g of x here, the entire function, 4x minus 1, is going to replace the letter x. So the easiest way to do this is to write f of x like this. So 2x plus 3. But instead of writing the letter x, this orange X up there that I just made, instead of writing that orange X, put parentheses and leave a little space like this. And then of course I have the plus 3. So just like kind of use your imagination here and imagine that says 2x plus 3. I just changed the letter X to parentheses with a little bit of space there. Well, in that space is where this 4x minus 1 goes, where that other function goes, the entire function. So now that you're here, all you have to do is distribute and combine like terms. So distribute the 2, that'd be 8x minus 2 plus 3, and then combine your like terms. My answer here would be 8x plus 1. That's what a composite function is. You place another function, in this case, the whole function 4x minus 1, inside of the previous function, and it replaces the letter x. So wherever there's an x, it gets replaced. As I do more of these examples, it'll make more sense. All right, this is basically just evaluating functions. There's a couple that are composites, and you'll see those, but for the ones that are just like a simple evaluate, just go find the function that you're supposed to plug it into, and just do a little bit of math and solve your answers. So like this one, plug in -1/2 right here. When it does greatest integer, that'll make -1 plus 3 is +2. I have -2, so now I'm on this I equation, and I'm plugging in -2. So that would be, when it's all said and done, -6 for my answer. I'm going to leave the composite for now. We'll just knock out all these evaluates first. J of 0, plug in 0 for this equation. So that's going to spit out an answer of 0. Leaving the composite, K of 6, just plug in 6 right here. So that's root of 4, which is 2. I know you're probably thinking about the plus minus here. Just leave it for now. Just leave it as 2. Leaving the composite for now, G of 3x plus 1. Okay, this one's kind of weird. If whatever they tell you right here has to take the place of the letter x. So I'm going to take this equation, negative x squared. Instead of writing the letter x, do like I did before. Leave a space with some parentheses. Then it's squared. So like, use your imagination. This right here says negative x squared, okay? Just like the equation that I'm supposed to do. Well, in that parentheses is where this 3x minus 1 is going to go. Like that. And honestly, I'd probably just leave my answer like that. I would not FOIL it out and then do the negative distribution. You could if you wanted to. But I would just leave this one as negative parentheses 3x minus 1 squared. If you FOIL this out and then apply that negative, you should have gotten negative 9x squared plus 6x minus 1. That would have been your final answer. Okay, now let's, okay, we have this one as well before we get to the real composites. So find your equation H, that is here. Wherever there's an X, it's now gonna say T plus 7. I'm gonna leave this 2 alone for a second. I'm not gonna mess with that. So it's like 2's just sitting out here. So this equation was 1 over x, but instead of writing the letter x, I put parentheses, and then minus 2, like that. Now in that parentheses is where this t plus 7 is going to go. T plus 7. Okay, now you could leave your answer like that, or you could distribute. I'm going to go ahead and distribute this one. It won't take but a second. It's going to be 2 over t plus 7 minus 4. All right, now we're ready for the composites. Here we go. We'll start with this one first, because if you can do that one, you can do all the others most probably. So g of f of, here's how you do these. You start with the insidemost thing, so h of 5. So you go to your h of x equation, here it is, and you plug in 5 for the letter x. So it's like 1 over, instead of writing x, I write 5 now, minus 2. 1/5 minus 2 is negative 9/5. So now I know h of 5 has a value of negative 9/5. So I go back here, and I'm going to change h of 5, underlined in red, to be that negative 9/5. Like that. Now, rinse and repeat. So I'm going to do f of negative 9/5 next. So I'm going to go find f of x. I'm going to plug in negative 9/5. It's going to spit out a value of 1. So I know, because if you plug in that greatest integer, negative 9/5, fine, I'll show you my work, plus 3. Negative 9/5 greatest integer is going to spit out a value of negative 2 plus 3, which has a value of 1. That's how I'm getting this. Okay, so I know f of negative 9/5 has a value of 1. So I can change that to just say 1. See how I'm working my way from the inside out? Now all I have to do is do g of 1. So find your g of x, plug in 1. Your answer would be negative 1. That's how you do those. Okay, let's look at some more examples. The next one I'm going to do is this g of negative 1/3. So the first thing that you have to do is start on the inside and do g of negative 1/3. So that means I'm going to plug in, instead of the letter x, I plug in negative 1/3 there. So it gets squared, that makes a 9th, and then the negative gets applied, so it's a negative 1/9. So now I could rewrite this as g of, we just said this has a value of negative 1/9. So g of negative 1/3 is really negative 1/9. So now I'm working my way from the inside out. So now all I have to do is go back to that g of x equation and plug in negative 1/9 this time. So that would look like negative parentheses, negative 1/9 squared. Negative a ninth squared is 1 over 81, and then the negative gets applied. So my answer here is negative 1 over 81. Like that. Okay, one more on this page. It's the I of f of 11 thirds. So start on the inside again. Do f of 11 thirds, this part. So go find f of x. Plug in 11 thirds. And by the way, I haven't been really writing this, but if it helps you, you can write it like f of 11 thirds equals, and then work it out. I kind of just keep track of that in my head, but it might help you see this a little better. So if you do this, f of 11 thirds is going to spit out a value of 6. So now all I have to do is this I of 6. I guess I can make that red to kind of color code it for you. 6 right there. Okay, so just go find I of x and plug in 6. That'd be 218. Because 6 cubed is 216 plus 2 is 218. All right, so that's evaluating composites. Let's look at more examples. This time, we're not using numbers. We're using equations. You should definitely prepare for this to be on like a quiz or a test. This is very important to know. Basically, what you're going to do here is you're going to take the inside part, g of x, and write whatever the equation is. So I haven't touched this f of yet, so it's still going to be sitting here, f of. Now I changed g of x to its actual equation, which is negative x squared, like that. Okay, now to do this, to get my answer, all I do is I need f of negative x squared. That means take f of x, and wherever there's the letter x right here, it's going to get replaced with a negative x squared. So what it would look like is this. It would be, instead of writing the letter x, I write parentheses negative x squared plus 3, because this plus 3 at the end. So I just did not write the letter x. I changed it to be negative x squared. That's how I got my answer. Let's look at more examples of this. K of I of x. Go find I of x. Don't touch K of. Just go find I of x. I of x is x cubed plus 2. So I can rewrite this as K of x cubed plus 2, like that. Now all I have to do is go find my K of x equation. And wherever there is a letter x, right there, it's going to change to x cubed plus 2. So what this would look like is root x cubed plus 2, and then don't forget this minus 2 that was in the original K of x, minus 2. And if you notice, the plus 2 minus 2 here will cancel. So your answer is actually just root x cubed, like that. All right, the next one, I of f of x. Go find f of x. F of x is x plus 3. So I can rewrite this as I of x plus 3, like that. All right, now all I have to do is go find I of x. It's here. Wherever there's a letter x, I'm now going to write x plus 3. So what that would look like is parentheses, x plus 3 cubed plus 2, like that. Okay, the next one, h of f of x. Go find, start on the inside, f of x. F of x is here. So that's x plus 3. So I can really rewrite this as h of x plus 3. So now h of x plus 3, go find h of x, and instead of writing the letter x, you're just going to write x plus 3. So that's 1 over x plus 3 minus 2. You should be getting the hang of this by now. j of f of x. F of x is x plus 3. So this is really like j of x plus 3. Go find j of x. Wherever there's a letter x, put x plus 3. So negative 2, absolute value bar of x plus 3, absolute value bar. The last one. Okay, the last one, k of g of x. Go find g of x is negative x squared. So this is k of negative x squared. Then go find k of x, and instead of writing the letter x, just write negative x squared. So it looks like root of negative x squared minus 2. And you could use parentheses there. I generally do. All right, now evaluating them from a graph is kind of similar. Basically, you're going to work your way inside out, and you're going to have to use the graph to find a y value. So here's what I mean by this. Start on the inside here, f of 2. Go find f of 2 right here. It has a value of 0. So like I could rewrite this equation as g of, we just said f of 2 had a value of 0. So now I'm just looking for g of 0. G of 0 is here. That's sort of the y value of 1. Let's try this again on the one below it. F of g of h of negative 4. So I'll rewrite it. F of g of h of negative 4. I know it can get kind of confusing because there's like a bunch of them, but just start your way, work your way from the inside out. So go find h of negative 4. Let me get rid of these dots so we don't get confused. H of negative 4 is here. It has a value of 0 right there. So that means I could rewrite this f of g of, you just said h of negative 4 had a value of 0. Now I'm going to work my way from the inside out again. G of 0. Go find g of 0. It is here. It has a y value of 1. So now it's like f of 1. So now all I do is I go to f and find where 1 would be on the graph. That would be here. That is a y value of negative 3. So that's how you do those. Okay, moving right along. I'm not going to color code these anymore. You should have the hang of it by now. This one's kind of tricky because there's a lot going on here, this one. So go find f of negative 2. F of negative 2 has a value of 0, a y value of 0. So this is like 2g of h of f of negative 2 is 0. All right, now go find h of 0. H of 0 has a y value of 2. So it's like 2 of g of 2. And then go find g of 2. G of 2 has a value of negative 3. So this is like 2 times negative 3, which has a value of negative 6. These other ones should be pretty easy compared to that one, except for maybe this last one, but let's just keep going. H of f of 0. Let me get rid of these dots so we don't get confused. H of f of 0, start with f of 0. F of 0 has a value of negative 4. So this is like h of negative 4. Let's go to h, go find negative 4. It has a value, y value of 0. G of 0. G of 0 is 1. So I can rewrite this g of 1. G of 1 is negative 1. Okay, these last couple. H of f of g of 2. G of 2 has a value of negative 3. So this is like h of f of negative 3. Okay, f of negative 3 has a value of 5. So this is like h of 5. H of 5 has a y value of 3. So my answer is 3. Now this last one, it's a lot of steps, but just follow the process and you'll be okay. F of 2, starting on the inside. Let me get rid of these dots. F of 2 has a value of 0. Now, f of 0 has a value of negative 4. H of negative 4 has a value of 0. And h of 0 has a value of 2. So that's my answer.